Okay, this is section 3.1, sequences of transformations. Our learning target for this section is I can apply a sequence of transformations to a figure. So we've learned how to translate an image, we've learned how to reflect an image, and we've learned how to rotate it. Now what we're going to be doing is we're going to be doing multiple of these transformations to one specific figure, okay? So let's look at example one. Example one says, draw the image of triangle ABC after the given combination of transformations, okay? So the first thing we're doing here, we're reflecting over line L, okay? And then the second thing is we're translating along the vector V, okay? Notice that the sequence, the order really matters. You need to do first the reflection and then the translation second. So we're flipping the image, then we're sliding the image. Step one right here shows us how we flip the image across line L. Um, Notice that point A stays on the line, point B goes directly across to create point B prime, and then C goes directly across, um, crossing the crossing the line of reflection at an angle of 90 degrees. All right, so we flip the line, we flip the figure across line L. Okay, now that we're done with that, notice how we label, right? A prime, B prime, C prime. That was my first transformation, okay? So when I do the translation now, the end picture is going to be A prime, A double prime, B double prime, and C double prime. It's very important that you keep track of that in that way with the prime notation. That way you know which comes first, which transformation came first and which came second, third, and so forth. So now that we reflected, so now we're going to take the figure A prime, B prime, C prime, and slide it with a translation of x plus 4 and y plus 1. That was my vector v right here. So when I slide the picture over, this is my final result. And notice that now I have triangle A double prime, B double prime, and C double prime. Okay, that's my final transformation. Um, Now, the next problem, I would like for you to try it on your own. So let's look at what the problem is asking you to do. Just want to walk you through a little bit, and then you can do it on your own after. Um, Draw the image of triangle ABC after the given combination of transformations. So here, I want to highlight, okay? The first thing you want to do is you're going to rotate, okay? So you're going to rotate around point P. Okay, then after you rotate, you're going to translate x plus 5, y plus 1. And then after that, you're going to reflect across line L. Okay, so notice that we have three transformations. We're doing one at a time in that order that it was given to you. What we're doing now is we're combining, erase this. What we're doing right now is we are combining non-rigid transformations, okay? So see how that's gonna look like when we combine non-rigid transformations. Example 2, draw the image of the figure in the plane after the given combination of transformations. So we are, first thing we're gonna do is we want to um, transform it, right, horizontally, and then times 3 on the scale factor. So we start with A here, right? Notice that I build my little table here, okay? A, B, C, I labeled the coordinates, and then I did my transformation, and I used the A prime, B prime, C prime notation, because that was my first transformation. So I multiply the X by 3, and the Y stays the same. So for A prime, I get 0, comma, -2. For B prime, I get -6, comma, -4. And then for C prime, I get -12, comma, -4. Notice that the Y's are the same, but the X values have been multiplied by 3, okay? Because that's what I was told to do here. Then my second transformation Okay, the second transformation is a dilation by a factor of a half. Okay, notice that I have a half here uh, to both of my coordinates, right? To the x and to the y. And then it's combined with a reflection, because notice that I have a negative y here. So that means that the picture is going to be reflected across the x-axis. Okay, because I have a negative y, so that means the picture is being reflected across the x-axis. I got my coordinate points from A prime, B prime, C prime. Notice that I didn't start from the beginning. I started from my second transformation already, okay? The first transformation that I did, that's where I apply my second transformation to. So I multiply by a half. The x is multiplied by a half, and I get these x's here, 0, -3, and -6. And then if I multiply the y's by negative a half, I end up with 1, 2, and 2 for my y coordinates. Once you get the points, I feel like it's really easy once you get the table done, okay? Then you can just plot the points and connect them. Now make sure that you label them, right? So you know which is which, okay? We started off with triangle ABC, okay? Then we did a dilation by a factor of 3 horizontally. So notice how the picture got stretched out. So that's triangle A prime, B prime, C prime. And then what we did is we applied a scale factor of a half to that picture, and then we flipped it over the x-axis. So we end up with triangle A double prime, B double prime, C double prime above the x-axis. All right, so this example here, it says we need to be able to predict the result of applying a sequence of transformations to the given figure, okay? So we're starting with a rotation of 90 degrees clockwise about the origin, and then we're dilating it by a factor of 2, okay? So remember that when we rotate clockwise 90 degrees, would be the same as rotating it counterclockwise 270 degrees, okay? So now what's gonna happen is this picture is gonna go over to quadrant 4, okay? So a 90-degree clockwise rotation will map it to quadrant 4, and due to its symmetry, it will appear to have been translated, okay? But it will be closer to the x-axis than the y-axis. So the square maybe would be somewhere around here, okay? Closer to the x-axis than the y-axis. Then when we do a dilation of by a factor of 2, remember you just multiply the coordinates by 2, right? X times 2 and then y times 2. So a dilation with a factor of 2 will double the side lengths of the square. Okay, it will also be further from the origin than the pre-image. Okay. The final result will be a square in quadrant 4 with side lengths twice as long, okay? So if you need to, you can always find the points, okay, and actually do the translations so that you can figure it out, do the transformation so you can actually figure out where the figure is going to end up, and then you're able to kind of describe in words what's going on with the